Hi, today we are going to discuss about insertion sort technique. The insertion sort is a sorting technique that can be used to rearrange elements of an array either in ascending order or in descending order. The name insertion means unsorted elements are inserted one by one into their proper position in an existing sorted array, but the input array is completely an unsorted array. So we need to divide the input array into two partitions such that one partition contains sorted elements and the second partition contains unsorted elements. Let me explain this with an example. Consider the following array having 5 elements: 57, 25, 48, 37, 12. We need to rearrange these elements using insertion sort technique. So the array is divided into partitions, two partitions. So the array is divided into two partitions such that first partition contains one element, second partition contains four elements. The first partition is treated as sorted array and the second partition is considered as unsorted array. The first partition contains one element, it is sorted array. Second partition contains n minus 1 elements or 5 minus 1 elements, 4 elements, it is unsorted array. Now the elements in unsorted array will be inserted into sorted array one by one. First 25 will be inserted in sorted order, then 48 is inserted into sorted array. After insertion of 48, the element should be in sorted order in sorted array. Then 37 also will be inserted. Then 12 also will be inserted. Inserting an element from unsorted array into sorted array is said to be a pass. So we are going to insert here 4 elements. So we need to have 4 passes. Suppose in general, if an array consisting of n number of elements needs n minus 1 passes because n minus 1 elements has to be inserted into sorted array. Let me explain the procedure of insertion sort pass by pass with an example. In this example, the array contains 5 elements and we are going to rearrange the elements in sorted order using insertion sort technique. For this, we are going to divide the array into two partitions. As there are 5 elements, first partition contains 1 element and second partition contains n minus 1 element, that is 5 minus 1 elements, 4 elements. In unsorted array, there are 4 elements. So all these 4 elements need to be inserted into sorted array. First 25, then 48, then 37, then 12. In the first pass, we are going to insert 25 into sorted order. So if you insert 25, so the sorted order becomes 25 and 57 and the second partition contains remaining 3 elements. Now we are going to insert 48, that is the next element in the unsorted array. So if you insert 48, that will be inserted in between 25 and 57. So the sorted array contains 3 elements, unsorted array contains 2 elements. Now next element 37 is going to be inserted into sorted array. So 37 is going to be inserted in between 25 and 48 so that it becomes 4 elements. A sorted array contains 4 elements. Now unsorted array contains only one element. That also is going to be inserted. So 12 is inserted in sorted array before 25 so that finally the array contains sorted array. So initially, the array is divided into two partitions. There are 4 elements. These 4 elements are inserted into sorted array one by one. Inserting an element into sorted array is said to be a pass. We need to have 4 passes. In pass 1, we have inserted 25. In pass 2, we have inserted 48. In pass 3, we have inserted 37. In pass 4, we have inserted 12 so that all the 4 elements have been inserted into sorted array in its sorted positions. Finally, the output of the array is a sorted array. The unsorted array contains 5 elements. It is divided into two partitions such that one partition contains one element, other partition contains four elements. First partition is treated as sorted array, second partition is treated as unsorted array. The four elements in unsorted array are going to be inserted in sorted array one by one. In the first pass, we are trying to insert 25 into sorted array. So 25 need to be compared with all the elements of sorted array. There is only one element in the sorted array. If you wanted to place 25 in its sorted array, 25 has to be inserted before 57. But there is no space in sorted array to insert 25. For this, we need to create a room. So we are checking, is 25 less than 57? Yes, it is less than 57. It has to be placed before 57. So to make room, 57 is shifted to its next position. So 57 is placed in next position by overwriting 25. Because 25 is already placed in a variable y, there is space, and 57 is shifted to its next place, and there is a space to insert 25 here. Now there are no elements to compare with 25, and 25 is placed here. 25. So 57 is shifted to next position and 25 is placed there. Now see, the sorted array contains two elements, unsorted array contains three elements. In next pass, the next element in unsorted array is going to be inserted. That element is copied into y, and this is going to be inserted into sorted array by comparing elements in sorted array. Now 48 is going to be compared with 57, then 25. Is 48 is 48 less than 57? Yes. So it has to be placed before 57. So 57 is shifted to next position. 57 is going to be placed in next position, and 48 is compared with 25. Is 48 less than 25? No. So 48 will be placed in the place of 58, 57. So now the sorted array contains 25, 48, 57. See, sorted array contains three elements, unsorted array contains two elements. Now we are going to insert 37, that is third pass. So 37 is copied into y, and 37 is compared with all the elements of sorted array, and it is going to be placed in its proper position. So 37 is compared initially with 57. Is 37 less than 57? Yes. So 57 is shifted to its next position. Then is 37 less than 48? Yes. So 48 is also shifted to next position. Is 37 less than 25? No. So 25 is not shifted, and 37 is placed in the place of 48. So that 25 is the first element, 37 is the next element, 48 is the next element, 57 is the next element. Now sorted array contains four elements, and unsorted array contains only one element. Now in fourth pass, the only element 12 is going to be inserted into sorted array. So 12 need to be compared with all the elements of sorted array. It starts comparing with 57 first. Is 12 less than 57? Yes. So 57 is shifted to next place. Is 12 less than 48? Yes. So 48 is also shifted to next position. Is 12 less than 37? Yes. So 37 is also shifted to next position. Is 12 less than 25? Yes. So 25 is also shifted to next position. Then is there any other element to be compared? No. So 12 is placed in the place of 25. So the sorted array contains now 12 in first position, 25 in second position, 37 in third position, 48 in fourth position, 57 is in fifth position. The sorted array now contains 12, 25, 37, 48, 57. After 4 passes, the array was rearranged as a sorted array. Now, in first pass, we made only one comparison. 25 is compared only with 57. So the number of comparisons are 1. In second pass, 48 is inserted. 48 is compared with two elements. So there are two comparisons. In third pass, 37 is inserted. and it is compared with 3 elements. After comparing 3 elements, 37 is inserted. So, number of comparisons are 3. In fourth pass, 12 is inserted after comparing with 4 elements. So, there are 4 comparisons. Total number of comparisons when we sort an array of 5 elements is 1 plus 2 plus 3 plus 4. In general, the array may contain n number of elements. The total number of comparisons will be 1 plus 2 plus 3 plus up to n minus 1. So, this 1 plus 2 plus 3 plus 4 plus n minus 1 may be treated as n into n minus 1 by 2, which is nothing but n square minus n by 2. The time complexity of any algorithm is directly proportional to the number of executable instructions or comparisons. In here, we consider the total number of comparisons. So the total number of comparisons are n square minus n by 2. The time complexity of insertion sort is order of n square.